solutions. Aren't we just solving it? Right? We're finding the x-intercept, right? Now, do not multiply this out and then go through and solve it by the quadratic formula. That takes way more time than needed. We like quadratics in vertex form. They're the easiest ones to solve. So don't we set it equal to 0 and solve? So we would isolate the x squared. Does everybody understand that's all the squared part?
Yeah.
Okay, so we subtract 49 from both sides. So we have x plus 3 squared is equal to negative 49, right? Before you square root it, the square part has to be alone. So don't we divide both sides by negative 1? Oops, negative 1. Okay, so what we have over here is the negative 1s divide out and become positive 1. So we have x plus 3 squared is equal to positive 49, correct? Negative 49 divided by negative 1. Then what will we do? Square root both sides of the equation. Our root cancels out with our power, leaving us x plus 3 is equal to what?
7.
What else?
Plus or minus 7.
Good, plus or minus 7. So we're not ever going to forget that from here this day forward. So then we know this is x plus 3 is equal to positive 7. This is x plus 3 equals negative 7. Solve for x. Subtract 3. X is equal to 4, right?
Yes.
Then we'll subtract 3. X is equal to negative 10. Now, a lot of people will go through, they forget the plus and minus, they get this answer, and then I say, you forgot the plus and minus, and they say, and I could point fingers at some of you, they say, oh yeah, so negative 4. Was it negative 4, the other solution? No, you got to put the plus and minus in the right spot. Okay, so same thing here. It says find the solutions. We're solving the quadratic. So if I said solve and I gave you this, would you do what we just did, right? If I said find the zeros and I gave you this, you do the same thing. So we'll set it equal to 0, isolate the square. So that's the square. So we'll add 12, right?
Yeah.
So x minus 1 squared is equal to 12, and then we divide by
3.
So we have x minus 1 squared is equal to 4, then we'll... So we have x minus 1 is equal to what?
Plus and minus 2.
Plus and minus 2, right? So then we have x minus 1 is equal to 2, x minus 1 is equal to negative 2, solve for x, add 1, x is equal to 3, add 1, x is equal to negative 1. Solving in vertex form is the easiest method out there. Yes?
Yeah, that's 3x minus 1 squared minus 12. If you minus the 3x minus 1 squared and you like put it on the other side, wouldn't that be negative 12?
So to get 12 over, we have to do the algebra, right?
Oh.
So you add it over, you can't float it over. Okay. Sweet. Okay, so finding the solutions, are you just finding the x-intercepts?
Yes.
Okay, awesome. Just making sure. We've already done that one. Okay. So this is the next one. If it says draw to grid the parabola, if you're drawing like a graph, don't you have to have a y equals an equation? So how would we get y along here?
Add 2.
So we'd add 2 back here. Now isn't it y equals?
Yes.
So we would just type that into our calculator, plot points, right? Now what if I put a 2 here?
Divide by 2.
Then we would divide both sides by 2, right? So we could write this as, now let's think on an advanced level, guys. Think about it. Isn't dividing by 2 the same thing as multiplying by 1/2?
Yep.
So isn't this 1/2 times x minus 1 squared for that piece? And then what's 2 over 2? So plus 1. So then couldn't we type that into our calculator?
Yep.
Okay, sweet. Then, next thing, okay, so there's a really important reason I'm going over this, so make sure you pay attention. This is new. It will be on the test. I wrote the test myself for it. So it says the quadratic. So we know quadratics have 2 solutions, right? 2 x-intercepts. If it has 2 x-intercepts, it definitely is quadratic, okay? So I'm going very slow for a reason. So if I said, okay, find the zeros, find the 2 solutions, I would solve by factoring, okay? It's equal to 0. We're looking for what multiplies to be 5 and adds up to be negative 6, right? 1 times 5, they're both negatives, right? That works here. Negative 1 times negative 5 is 5, and negative 1 plus negative 5 is negative 6. So this quick factors to be x, you put those right in, right? X minus 1, x minus 5 is equal to 0. Now look, isn't this the same thing as this? This is factor form, standard form.
Yeah.
So to get it from standard form to factor form, we factored it, right? Now we know that these are linear factors. When I say linear factors, it should say in your head, linear means degree 1. This is a linear factor, degree 1. X is degree 1, right? And now we know we can spread apart our linear factors and set them individually equal to 0, right?
Yeah.
Then we solve for x. So when we add 1, so x is equal to 1. So we'd add 5. X is equal to 5. Okay, so we solved this, we found the solutions. Now today we have to be able to go backwards. So given the solutions, work backwards. So everybody look up here. So let's think about it. If I said, okay, so the solutions are this picture, 1 and 5, right? So you'd say x is equal to 1, x is equal to 5, because that's where it's crossing. If I said find the equation of this line using these zeros, I want to see your work, we'd work backwards, right? So let's think about it. Let's work backwards. If this is the answer, wouldn't the linear factor have been set equal to 0? So I would subtract 1 from both sides. Wouldn't that be x minus 1 is equal to 0? Isn't that the linear factor that gave us the answer x is equal to 1?
Yes.
So working backwards, we'd subtract 5.
X minus 5.
So x minus 5 was the linear factor that gave us 5. And now, look, do you see how we're going backwards?
Yeah.
Now when they were apart and equal to 0, before they were pulled apart, we had them multiplied together like this, right? Is equal to 0. And then if I said, and find the polynomial in standard form with these zeros, is this standard form? No, this is factor form, but we can quickly find standard form, right? X squared minus 5x, right? Minus 1x, and then plus 5. So we get x squared minus 6x plus 5, and look, we went backwards. Okay? Because I didn't, this is the reason. So, what's the equation that has these solutions? So, don't we need to go backwards again?
Yes.
If it has these x-intercepts, let's find the linear factors that gave us these x-intercepts. So, we're writing the equation in standard form. So, if this is where it crossed the x-axis, the linear factor would have been set equal to 0, right? So, the linear factor x plus 1 is equal to 0 gave us x equals negative 1. Are we all comfortable with why this is working? Because it's going to be a lot easier if it makes actual sense. So, the linear factor to give us x is equal to 2 was equal to 0, so we have x minus 2 is equal to 0. Now, before we split them apart and set them equal to 0, we had them together being multiplied equal to 0, right? And if I say I want it in standard form, then this is factored form, so we'd multiply it out, x squared minus 2x plus 1x minus 2 is equal to 0. Combine like terms, x squared minus 1x minus 2 is equal to 0. Isn't this the polynomial that generated these zeros?
Yes.
Okay, so this is the polynomial in standard form. So we went backwards. That will be on the test, I can promise. So looking at this one, xy, xy. These are xy intercepts. So this is the x-intercept. So let's look. Over 0 up 0. Wouldn't that be crossing the x-axis here? Over 4 up 0. So we get x is equal to 0, x is equal to 4. Okay, let's work backwards. What's the polynomial that has those two zeros? So we have x is equal to 0, and then wouldn't we subtract 0 from both sides?
Yes.
So we have x minus 0 is equal to 0. Can't I just write x is equal to 0?
Yes.
Okay, and then we have x, wouldn't we subtract 4? And then we multiply those two things. Before they were split apart, they were multiplied together. So x times x minus 4, right? And then we would multiply it out. That's x squared minus 4x is equal to 0. You see how we work backwards?
Yes.
There's the polynomial that generated the zeros for x is equal to 4 and x is equal to 0. Okay, so we're working backwards. You'll see this in secondary 3.
Weird.
So it says create a quadratic that has real coefficients and real number solutions. So if it has real solutions and it's a quadratic, how many solutions? 2, right? So wouldn't a real solution be any real number?
Yep.
I could do x is equal to negative 3 and randomly x is equal to 4. Aren't those real solutions?
Yes.
Yeah. So then I would multiply it out, go backwards, right? Find a polynomial. You have to work backwards though, because if you made one up on the fly, like I had someone going, okay, I'm just going to make one up but then their solutions actually came out imaginary. That's why we go backwards, to ensure that we're good. Does that make sense? Sweet. Okay, 22. Let's do it together. So we're simplifying this on 8-8. Let's get rid of 24 minus 5 square roots of negative 12 plus 3. So we're going to simplify this down. This is to write it in the form of a plus bi. So when you see a plus bi, you should say that's a complex number, where this is the real part and this is the imaginary part. So we can combine real numbers with real numbers, imaginary numbers with imaginary numbers. So we break down 24. That's 6 times 4, 2 and 2, 3 and 2. Yep, there's 2 2s, so we can pull out a 2. Left is a 3 and a 2, which is 6. 2 squared roots of 6. Then right now we have negative 5 times all this stuff. Let's simplify. 4 and 3, 2 and 2, yeah? So we're pulling out a 2, we're pulling out a I. So don't we have negative 5 times 2i on the outside? What's that? Left under, right? Square roots of 3, right?
Yep.
The most common mistake is people forget the negative 5 that was in front. And then we have plus 3. So really right now we have this. 2 square roots of 6 minus 10. Can't you multiply a real number with an imaginary number? Yeah, right? 2 times I is 2i, right? So this will be negative 10i square roots of 3 plus 3. Does everybody see that this is an imaginary part? Okay, so these are the real parts. So let's see. We have 2 square roots of 6 plus 3 minus 10i square roots of 3. So there's our real parts, and there's our imaginary parts, right? So now understand something. 2 square roots of 6 plus 3, you can't combine. You can't say that's 5 square roots of 6. That's wrong. You can't combine them because they're not both square roots of 6. Just like you can't combine 2x squared with 2x. Does everybody understand that? So this would be our final answer. That is a plus bi, because that's the furthest we can go with combining these. Does that make sense, everybody? Technically, we could combine them, but it's going to be a really long decimal. So you could, let's do this. Type it in your calculator. 2 square roots of 6, close your parentheses, plus 3. You'll get a decimal. Does that make sense, everybody?
Yes.
So you can't combine those? Okay. So, I mean, I would accept that answer, or for this one, I would accept this. So 2 square roots of 6 plus 3. You should have got the decimal 7.898979486 minus 10i square roots of 3. That answer is acceptable as long as you put the full decimal. A plus bi. Now I do want you to note something. What if I change the problem? Changing the problem. Let's say we simplified something down and we have 2 square roots of 6 plus 3 square roots of 6 minus 10i square roots of 3. Now what's 2x plus 3x? 5x. So 2 square roots of 6 plus 3 square roots of 6 is how many square roots of 6? So 5 square roots of 6 minus 10i square roots of 3. This would be the most appropriate answer. I would not accept a decimal on that one because you could combine them. Does that make sense, everybody? The square root of 6 part didn't change. Okay, write in vertex form. So this is in standard form. What if I said write in factored form? Wouldn't we just factor it? We wouldn't solve it, though. We'd be done at factoring, right? Does everybody understand that? But it's asking us to write in vertex form. Well, this is in standard form. Standard form of a quadratic is ax squared plus bx plus c. Vertex form of a quadratic is a times x minus h squared plus k. So we did this. We changed from standard form to vertex by completing the square. So you may have to remember how to do that. Completing the square was the method of just rewriting it in vertex form. You take b divided by 2 squared. What's my b value, including the negative?
Negative 4.
Divided by 2 squared, which is negative 2 squared, which is 4. That was our square, right?
Yep.
Now you inserted your square after your bx. So we have x squared. We have minus 4x. We add our square. Then we have to even it out by subtracting our square, right? And then we still have our minus 2. Does everybody see how I inserted my fancy 0 where that star is? So then we put that in, that's a 4, that's a 4. Then we group the first 3 terms and we group the last 2 terms and add. So let's factor this. We're looking for what multiplies to be 4 and adds up to be negative 4, right? 2 times 2, negative, negative. Quick factoring. That's x minus 2 times x minus 2, right? What's negative 4 plus negative 2?
It's negative 6.
And our final answer would be taking this. Once again, this is equal to this. This is almost there. We're in vertex form. Isn't that the same thing as x minus 2 squared minus 6?
Yes.
So this is in vertex form. Have we solved anything? No, we've rewritten it in vertex form. We're done. Does that make sense, everybody?
Yes.
Okay. Sweet. Finish that worksheet, then start on the test review. You need to get a couple pages of the test review done, but you need to get this done too. I promise there's problems off of that back page. Wrote the test Friday.